So we're going to add and subtract rational expressions, starting with like denominators, meaning that at the bottom of my fraction, both expressions are exactly the same. If that happens for me, what I like to do is just go ahead and combine them and place them into one fraction. So I'm going to have one big fraction bar. And since they both have 4x cubed plus 20x squared, that's what I'm going to write on the bottom. However, I personally like it in factored form. So I'm going to divide both terms by 4x squared. And when I do that, what's left over goes into a set of parentheses. That means it's in factored form. So 4x cubed divided by 4x squared, the 4's go away, and then I subtracted 3 minus the 2, leaving me with 1x. Bring down this sign. 20 divided by 4 is 5, and then x squared divided by itself turns into 1. So that is the new factored form of my denominator. On the top, my numerator, I can just put it all together. So x minus 3, there's a plus sign in the middle, and then x minus 5. I can further simplify by combining my like terms. I have two x's, so that's how I'm going to rewrite it, 2x, and then I have a negative 3 plus a negative 5, which is negative 8, and that's all over 4x squared times x plus 5. Well, if I look at the top on the numerator, I see that I can further simplify that. So that's what I'm going to do. And that means I can divide both of those terms by 2. In doing so, I'm left with x minus 4. If I want to double check my work, then I can multiply it out. So 2 times x is 2x, 2 times negative 4 is negative 8. So whatever's on the outside, I'm dividing both terms by. What's left over, it goes in the inside of my parentheses. So what's in the set of parentheses is all together. So x minus 4 is one expression, and so is x plus 5. So I cannot take out one x here and one x here. Some people try to do that. You can't do that. I can, however, do that for what's on the outside. So what's on the outside here is a 2 and a 4. So if I simplify that and I divide it both by 2, I end up with a 1 here, and then 4 divided by 2, I end up with a 2. Well, I can't simplify anything further. So my final answer is going to be what's left over, which is x minus 4 divided by 2x squared times the quantity of x plus 5. So again, if I wanted to put that in parentheses just so I can see that's one expression, I cannot simplify any further. So this is my final answer for this situation, where this problem. Now, you don't have to do this, but I do want you to make a practice of it, because once we start solving, you're going to have to identify the excluded values. So what can x not be? The easiest way to identify it is to look at your factored form of your original denominator and set each term or expression equal to 0 and solve for that variable. So 4x squared equals 0. Well, I know once I divide 0 by a number, it's simply going to be 0. So x cannot be 0. Here, x plus 5 is set equal to 0. I'm going to subtract 5 from both sides, so x becomes negative 5. Those are the two numbers that I cannot substitute in for x, because if I do, it's going to make my denominator 0. And if you know anything about fractions, you cannot have a 0 in your denominator. It will give you an error in your calculator, and it's undefined. Try it. Take any number like 7 and then divide it by 0. See what your calculator tells you. You cannot have a 0. So these are the numbers that will make your denominator 0. So those are the numbers that are called excluded values, and we don't want those. All right, so let's do another problem. And again, they both have the same denominator. So what I'm going to do is just go ahead and make one big fraction. And I'm going to take what's on top and go ahead and rewrite it. So n minus 2 plus sign n plus 1. For me, I like to put it in factored form. If you have forgotten how to factor, what you can do is go to the side over here. Let's just create a box with 4 squares in it. For that first term, we're going to always put that in the first box. And the last term, we're going to always put in the last box. So I multiply these numbers, 2 times 3, that's 6. And then I'm looking for two factors that will multiply to give me 6, but those same two factors will have to add together to give me this middle number. So I want to replace this negative 7n with two numbers. So if I know my factors here, I know 6 times 1, but then I also have to take into consideration the signs because 6 times 1 is 6, but 6 plus 1 is not negative 7. So if I chose a negative times a negative still gives me a positive, but a negative plus a negative gives me a negative. So that's what I'm going to put here. But again, I'm replacing 7n, so I also have to put the variable, negative 1. And now what I'm going to do is I'm going to factor going to the left and also going up. This is how I factor. You don't have to factor this way if you're more comfortable using another method. So I asked myself on the first row, what's the greatest common factor between 2n squared and negative 6n? I know that it's 2n. And then I do the same for the second row. The sign that's closest to where I'm writing is the sign that's going to come out. And if I look at this, I know negative 1 and 3, the only thing that they share as a factor is 1. And now going upward, I'm doing the same thing. Well, I know between 2 and negative 1, the only number that they share is 1. So then I look at my variables so I can bring out an n. And it's a positive n because the box that's next to it is positive. This box that's next to where I'm writing is negative, so that's the sign that's going to come out. And then I can divide both of those numbers by 3. Those are my factors. So I want to take that information and that's what's going to replace this original polynomial. So it doesn't matter if I use the n minus 3 first or the 2n minus 1. I'm just going to go ahead and go with the 2n minus 1 first and then multiply it times n minus 3. Those are my factors, but it means the exact same thing as the 2n squared minus 7n plus 3. Now what I want to do is I want to go back and I want to combine my numerator. So I have an n and another n. So n plus n is going to result in 2n. And then I take the negative 1 plus 1, and that's negative 1. Now, if I divide it by my common denominator, my denominator that's already there, I notice that I can go ahead and I can take away this 2n minus 1 and this 2n minus 1 because it's the same thing. It's just like dividing 3 by itself. It's going to become 1. And that's important because when you have a fraction and you take away everything that's on the numerator, you have to replace it with a 1. Why is that true? Because my final answer is going to be 1 over whatever's left over, n minus 3. So this is my actual answer for this problem. Again, you don't have to do this step, but I want you to get in the habit of it, identifying what can x not equal? What is your excluded value? It's easy to see when it's in factored form. If I were to set this equal to 0 and solve for n, I'm simply going to change the sign of my constant, which is positive 1, and divide it by what's in front of my variable. So I know that x cannot equal 1/2. Same thing here. N minus 3 set equal to 0. I can just add 3 to both sides, and I know that n cannot equal 3, or I can use that same method. Change the sign of my constant, which is a positive 3, and divide by what's in front of n, which is 1. 3 divided by 1 is simply 3. That's my excluded values. So what I just did was for problems that have the same denominator. Let's look at some that have unlike denominators. All right, so denominator is what's at the bottom of your fraction, and they are clearly not the exact same expression. So now I'm going to rewrite it. What's missing on this side of my fraction for the denominator is what I want to multiply the numerator and the denominator by. So it's missing x plus 3. So that's what I'm going to do. I'm going to write x plus 3 divided by another x plus 3, and then my original fraction. I'm going to multiply it times that. So x minus 4 was my original denominator. So now on this side, I'm going to do the exact same thing. I'll just go ahead and bring down the 4x plus 3. And then what is missing on this denominator? Well, that x minus 4 is missing. What I do to the numerator, I have to do to the denominator. Okay, so once it's in this form, what I need to do is just go through and I want to distribute it out. So here my signs do not change. Here they do. I have to pay attention because now that negative is affecting everything on this side, this numerator for the second fraction. So let's just go ahead and rewrite this as one big denominator. So this is going to become x plus 3 times x minus 4. That's how I do it. You don't, again, you can keep them separate if you want to. And then 6x times x is 6x squared. 6x times 3 is 18x. This is the side where you have to be careful because some people will forget that minus sign. So negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Okay. So now I want to go ahead and combine my like terms. I see that I have two x's in there, so I can go ahead and put those together. And my final answer is going to be 6x squared plus 14x plus 16 all over x plus 3 times x minus 4. I said my final answer because I know that this is not factorable. It depends on your teacher. If they want to see that you can factor out like a greatest common factor, you can go ahead and do that, but you're really finished. So let's do that just so that you can see what I'm referring to. All right, so I am going to take out the greatest common factor, which is 2. And then I'm left with 3x squared plus 14 divided by 2x is 7x. And then 16 divided by 2 is 8. And then I use x plus 3 times x minus 4 as my denominator. If I tried to do the math here and factor this out, I can't find two factors that will multiply to give me 3x squared plus 7x plus 8. So I'm really finished right here. Now, in terms of my excluded values, I go back to my original denominators and I notice it's already in factored form. So it's easy to see if I were to set this one equal to 0, that I can't have 4. I cannot have a positive 4 because it will make this denominator 0. And if I set x plus 3 equal to 0, I cannot have a negative 3 because that would make that denominator 0. So again, you're asking yourself, what can I put in the place of x to make this denominator 0? Whatever that number is, I don't want it. It's called an excluded value. Okay. And then finally, let's go to this last problem. And again, it's unlike denominators. So that means that I'm going to have to multiply one side by, let's find another color here. Okay, I am going to have to multiply this first fraction by what's missing in the denominator. So this is what's missing. So I'm going to multiply by 3p plus 4. What I do to the top, I have to do to the bottom, times 5. So that same 3p plus 4 that was missing, I'm going to multiply it times what's already there, which is p minus 1. This time I have a subtraction sign. Well, I have a subtraction sign in between, so I have to pay attention to that. And I'm just going to rewrite this as 3 over 3p plus 4 because that's what's already given. And now I have to ask myself, well, what's missing? What's missing is the p minus 1. So what I do to the top or the numerator, I have to do to the bottom, meaning I have to multiply it on both the numerator and denominator. So now I notice that my denominators are exactly the same. So that's awesome. What I want to pay attention to is I have a negative sign. So that negative sign is going to affect everything that's inside of this set of parentheses, meaning it's going to change the signs. So over on this side, I could still have to distribute, but I do not have to change the signs. I only change the sign where for the second fraction because the second fraction is affected by that negative sign. It follows that negative sign. Okay, so what I'm going to do is go ahead and distribute this out, and I end up with 5 times 3p, which is 15p, and then 5 times 4, which is positive 20. I'm going to just set this up as one big fraction. So negative 3 times p is negative 3p, and then negative 3 times negative 1 is positive 3. I'm going to go ahead and put my factored form of my denominator underneath. And again, I can simplify. You will be tempted to try to combine these like terms that are in the middle, but this was the one that actually has a p, not this one. So 15 and negative 3p, I'm going to rewrite this as 15 minus 3 is positive 12p. 20 plus 3 is 23. And now, again, I use that same denominator, which is 3p plus 4 times p minus 1. I noticed at the top, I can no longer factor that, so I'm finished because there's nothing that I can eliminate or cross out. Going back to what I cannot use because it will make my denominator equal 0, x cannot equal, again, I'm going to look at my original denominator. Well, it's right here, but this is easier to see. So 3p plus 4 equals 0. The easiest way is to change the sign of the constant, which makes that negative 4, and divide it by what's in front of your variable, which is 3. So p, let's change that. I'm so used to saying x, we used p this time. P cannot equal negative 4/3. And same thing here, p minus 1 equals 0. If I solve for p cannot equal 1. And so that's simply setting your expression equal to 0 and solving for the variable. That's how you determine what your excluded values are. All right.